Today's learning targets are I can graph the inverse of an exponential function, and I can describe the basic features of a logarithmic graph. So yesterday you learned about what a logarithm was, and today we're going to be talking about how to graph them. So we're going to start with some review. We graphed exponential functions a couple weeks ago, so we'll start with that, and then we'll talk about how to turn that into a graph of a logarithmic function. So we're going to start by looking at the graph of f of x is equal to 2 to the x. So when we did these a couple of weeks ago, we came up with a parent table of values, and we generally use the x values -2, -1, 0, 1, and 2. And the corresponding y values, we're just taking these x values and putting them where x goes in the function. So this is really telling us to evaluate 2 to the -2 power, which we know is 1/4. This is 2 to the -1 power, which is 1/2. This is 2 to the 0, which is 1. 2 to the 1 is 2. And then 2 squared is 4. So let's just start here. And let's graph these values on our coordinate plane. I'm just going to do my best to kind of estimate where these fraction values are. And we know that the graph of an exponential function looks something like this. And we are going to be careful to not cross that x-axis because we know that is our asymptote. And let's answer a couple questions about this graph. So we talked about the end behavior. Basically, what is the end of the graph doing? So I'm skipping down here to D. What is the end behavior of this graph? Well, on the left side, I can write this as x approaches negative infinity. What is our graph coming really, really close to, or what is our graph doing? Well, our graph is approaching that horizontal asymptote of 0. So I'm going to say as x approaches negative infinity, our graph is approaching the asymptote of 0. Well, what is it doing on the other end? So what is it doing on the right side? So as our x values approach positive infinity, or on the right side of our graph is increasing. So I'm going to say on the other end, as x approaches positive infinity, our graph is going upwards. So our graph, or f of x, is approaching positive infinity. And let's talk about the domain and the range of this while we're at it, just to kind of concentrate on just the exponential part, because we'll kind of go back and fill in the rest afterwards. So I'm down here at question 1. What are the domain and range of this graph of f of x? Well, the domain we know has to do with the x values. So what x values does this graph contain? Well, the graph can go to negative infinity, or the graph can continue to go positive infinity. So I'm going to say the domain is all real numbers. So negative infinity to positive infinity. What is the range? Well, the range talks about the y values. So we know that the graph is going to come really, really, really close to the 0, but it's never going to touch it. And the y values are going to continue to get really, really, really big. So our range is going to be from 0, and I'm not going to include it because we're not touching the 0, to positive infinity. So now that we know what this graph of 2 to the x looks like, and we've kind of reviewed the end behavior and domain and range, let's talk about the inverse function. So going back to what we talked about in the fall, we know that if f of x is a one-to-one function, then the graphs of f of x and the inverse, remember that the inverse is denoted by this like -1 exponent, are reflections of each other about the line y is equal to x. So what I'm going to do is I'm going to sketch in on my coordinate plane over here the line y is equal to x, just so we kind of have a reference. I know this is a little bit messy, but so there's my line y is equal to x. And in order to get the reflection over that line y is equal to x, remember that in our table of values, we just basically flip-flopped our x's and our y's. So from this table that I have over here with this exponential function, to get the inverse function, I'm just going to take these x's and these y's and switch them. So now my x column over here is going to become my y column over here. So put my -2, -1, 0, 1, and 2. And my y column over here is going to become my x column over here. So 1/4, 1/2, 1, 2, and 4. And I'm going to go ahead and graph this on my coordinate plane. And hopefully when I'm done, it will look like a reflection over this line y is equal to x of our exponential function that we already have here. So 1/4, -2. Again, I'm just kind of estimating where these points are going to go. 1/2, -1. There's my 1, 0. There's my 2, 1. And there's my 4, 2. So my graph is going to look something like this. And I'm going to be careful on this side here. And the reason for that is the graph of an exponential function had an asymptote going this way. The graph of a logarithmic function is going to have an asymptote going this way. So let's fill in what we know about this inverse graph now. So the end behavior of our inverse function, or that purple graph that I just plotted in there, I'm going to start again with the left side of the graph, but our notation is going to look a little bit different now because our x values aren't actually going to -infinity in this case, because you'll notice that the graph doesn't cross over this vertical line or the y-axis. So I'm going to say that my x values are going to come really, really, really close to this value. So instead of saying as x is approaching -infinity, because it's not, we're not crossing over this line, I'm going to say as x approaches 0. And again, this is 0 because that's where the x values are 0. And I want to know, as x is approaching this line, what is my graph doing, or what is my f of x doing? Well, my f of x, or my graph, is going downwards. So if we're going downwards, another way that we can write this is f of x is approaching -infinity. Well, what are we doing on our other end? Well, on our other end of our graph, the right side, we'll notice that the x values are actually approaching positive infinity. So as x approaches positive infinity, what is our graph doing? Well, as the numbers are going to get larger and larger, our y values are also going to get increasingly larger. So I'm going to say f of x is going to be approaching positive infinity. So let's talk about the domain and the range of this graph. So the domain, or the x values, again, I'm not going past this x value of 0. So we're actually starting and going from 0, and my x values are going to continue to positive infinity. My range, again, that's the y values. Well, my y values are really, really, really big negatively over here, and my y values are going to continue to get big positively over here. So the range is actually -infinity to positive infinity. And you'll notice that the range of our exponential function is now the domain of our inverse function, and vice versa. The domain of our exponential function has now become the range of the inverse function. And we're going to answer one last question. Does the graph of the inverse have any asymptotes? Yes, we talked a little bit about that. Again, the graph of an exponential is going to have an asymptote going this way. The graph of the inverse function is going to have an asymptote going this way. So when we were talking about exponential functions, our asymptote was written as y equals because that was a horizontal line. But now we're going to say that the asymptote is going to be written as a vertical line. So this is actually going to be written as x equals 0. And we'll look at more examples on the next page. So you talked about yesterday rewriting exponential to logarithmic and vice versa. So that's going to be helpful when we're actually writing the function of the inverse. So in the example that we just looked at, the exponential graph that we started with was f of x is equal to 2 to the x. What we can say is the inverse function is actually log base 2 of x, which is the inverse of 2 to the x. So starting from the beginning, how do we go about actually graphing these? So I kind of gave you guys some steps to follow. We're going to make a table for the parent exponential function. We're going to state or switch the x and our y values in our table to create the parent logarithmic function. And this is going to be pretty similar to what we were talking about when graphing exponentials. There's no one parent logarithmic function. It just depends on what the exponential function is to begin with. And then we're going to state the domain, range, and end behavior of our logarithmic function. So this example is asking us to graph f of x is equal to log base 3 of x. So the way we're going to determine what the exponential function is really by this base here. So the base, or log base 3, has a parent exponential graph of f of x is equal to, if that base is 3, the base of my exponential graph is also going to be 3. So I'm going to write this as 3 to the x power. And again, we're pretty familiar with graphing exponential functions that look like this. So I'm going to start with my x values of -2, -1, 0, 1, and 2. Again, I'm just graphing the exponential function. So this is asking me to take 3 to the -2 power, which is 1/9, 3 to the -1, which is 1/3, 3 to the 0, which is 1, 3 to the 1, which is 3, and 3 squared, which is 9. So that's my parent exponential, but we're not graphing exponential functions. We want to know what the parent logarithmic function looks like. So I already know what my logarithmic function looks like. That's what it's asked me to graph up here. So I'm just going to rewrite that down here. So f of x is equal to log base 3 of x. And to get this table of values, again, I'm just going to go ahead and take these x's and these f of x's, or these y values, and I'm going to switch them. So the x's are now going to become 1/9, 1/3, 1, 3, and 9. And my y's, or my f of x's, -2, -1, 0, 1, and 2. And that's what I'm going to graph on my coordinate plane over here. And then again, I'm just going to kind of estimate where those fractional values are. So something like this. And 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And my graph is going to look something like this. And again, similar to the exponential functions, I'm going to be careful. I'm seeing that this kind of first dot that I graphed is pretty close to the y-axis. I'm going to continue my graph down, and I'm going to be very careful to not actually hit that. And sometimes you'll see the asymptote dotted in. So I'm going to dot in an asymptote here just to show that my line is going to come really close, but it's never going to touch. And then I'm going to go ahead and state the domain and the range and the end behavior. So the domain here, the x values, again, we're coming really close to the 0, but we're never actually going to cross it. So we're starting our domain at 0, and we're going to positive infinity, because again, I'm talking about the x values. The range, or the y values, I'm getting really large negatively here, and as the x values continue, it's going to become really large positively. So range is negative infinity to positive infinity. And the end behavior, again, I'm going to start on the left side of my graph. I know we're used to writing as x approaches negative infinity, but we're not, because we're approaching 0. So as x approaches 0, because that's the line I'm getting really close to here, my f of x, or my graph, is going downwards, or approaching negative infinity. On the right-hand side, as x approaches positive infinity, or up here, my graph is also going to keep on increasing. So f of x also approaches positive infinity. Let's look at one more example. So this one's a little bit different, because now you'll notice that the base is now a fraction, but that doesn't really matter because we know how to deal with fractional bases with exponentials. So to identify the parent exponential, again, that's going to be that number that's in the base of the log. So I'm going to write my parent exponential as f of x is equal to 1/2 to the x. And to get this table, again, I'm going to start with my -2, -1, 0, 1, and 2. And my f of x values, I'm going to raise 1/2 to the -2 power, which is actually going to be a +4. 1/2 to the -1, which is going to be a +2. 1/2 to the 0, which is 1. 1/2 to the 1, which is just 1/2. And then 1/2 squared is 1/4. And now I'm going to go ahead and switch those. get my parent logarithmic function. And again, the parent logarithmic function is just the one that we have up here. So f of x is equal to log base 1/2 of x. And again, I'm just going to switch these. So my x's are now going to become 4, 2, 1, 1/2, 1/4. And f of x, -2, -1, 0, 1, and 2. I'm going to go ahead and graph this table that I just came up with. So 4, 1, 2, 3, 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. So you'll notice that these dots are kind of going in a different pattern. There's a reason for that, which we will talk more about in a second. I'm just going to connect these. So my graph's going to look something like that. And the reason that the graph looks different is because of this base. Before we had an integer base, but now we're dealing with a fractional base. So our graph is going to look different. So let's talk about the domain here. So the domain, again, with the logarithmic function, we're going to be coming really close to some line. In this case, that's the y-axis again. So our x values are never going to cross over 0. So our domain is going to be still 0 to infinity. And again, not including the 0 because I'm never going to touch that value. The range is actually still -infinity to positive infinity. Remember, we like to read the range from the bottom up. As the x values get really big, these values are going to continue to decrease. And the end behavior, so over here, as x is approaching, again, I'm going to kind of start with the left side of my graph. X is not going to be approaching negative infinity because we're not crossing over this vertical line here. So as x is approaching 0, because that's what this side of the graph is doing, my f of x is going upwards. So we can say it's approaching infinity. And as x approaches positive infinity, because I'm going on the right side here. So as x is approaching positive infinity, the graph is actually going to continue to kind of go downwards. You'll see kind of like this tail is going down. So we're going to say f of x is approaching negative infinity. So now it's your turn to try some practice. Let us know if you have any questions.